I am Dr. M. Tamil Professor, Department of Civil Engineering, Rohini College of Engineering and Technology. Net positive suction head. So, net positive suction head is otherwise called Npsh. So, in this centrifugal pump, drawing liquid from a sump open to atmosphere. So that Hs is equal to vertical distance between the center line of the pump and the free liquid surface of the pump. Hs is a suction head. Suction head, vertical distance between the center line of the pump, the free liquid surface from the sump. From the sump level to the center line of the pump is known as suction head. And the velocity of the liquid in the suction head, that is Vs. In the suction head, the velocity of the liquid is known as suction head velocity Vs. Then HFS. HFS is equal to losses in the suction pipe up to the pump inlet. That is Fs signals, it is losses in the suction pipe up to the pump inlet. And then P1 is absolute static pressure at pump inlet. P2, Pa absolute atmospheric pressure. PV vapor pressure of the liquid for a given temperature. These are all the net positive suction head is mainly velocity of liquid, losses in the suction pipe, vertical distance between the center line of the pump, absolute pressure, vapor pressure. These are all the terms using the net positive suction head. This is the diagram. In this diagram, this is the pump. In this pump is sump. From the sump, so Pa is the atmospheric pressure. From the atmospheric pressure to the center of the pump is known as suction head. So from the atmospheric pressure, Pa from the sump level to the discharge level is known as Pa by W. Pa is atmospheric pressure by weight density of water. So from the center line of core, this is P1 by W. HFS is loss, V square by 2G is a kinetic energy. This is the net positive suction head diagram. From the diagram, we have identified. Okay. Now, the pump will work without cavitation if P1 is greater than PV by the amount of equal to that required by the liquid for increasing in velocity head when entering the impeller. If this amount be denoted by HSV, we can write P1 by W is equal to PV by W plus HSV. So P1 by W is equal to Pa by W minus Hs plus Hfs plus V square by 2G. So kinetic energy of the suction head. So from the equation 1 and 2, HSV is equal to Pa by W minus Hs plus Hfs plus V square by 2G minus PV by W. So HSV is equal to HA minus Hs minus HV. So HA is equal to Pa by W and HV is equal to PV by W. So where H is equal to total suction head is equal to Hs plus Hfs plus V square by 2G. In this Hs value you have to substitute here. So the value of HSV is frequently called the net positive suction head. The value of HSV is frequently called as a net positive suction head. Thus, the net positive suction head may be defined as the difference between the net inlet head and the head corresponding to the vapor pressure of the liquid. The net positive suction head may also be defined as the net head that is required to make the liquid flow through the suction pipe from the sump to the impeller. The term has significance only when cavitating liquids are handled. The net positive suction head is a parameter that can be used to check cavitation in pump. The term net positive suction head is frequently used in pump industry. The minimum net positive suction head depends upon the pump design, its speed and the discharge. From the equation 2, the limiting value of suction lift, that is Hs, is given by Hs equal to Pa minus Pv by 7 by W minus Hfs minus V square by 2G. So suction lift, that is Hs, is equal to Pa minus Pv by W minus Hfs minus V square by 2G when P1 is equal to PV. Suction height is usually limited from 7 to 8 meter. The permissible suction lift would be less at elevated pump elevation since atmospheric pressure diminishes with altitude. The suction lift should be no case be more than that given by the equation. Otherwise, due to reduction in pressure, rapid vaporization of the liquid may occur, which may ultimately lead to cavitation.